Have you ever stopped to think about the secret powers hidden inside simple shapes? I mean, take a shape that just looks like a squashed circle. Turns out it governs everything from secrets we whisper to the paths of entire planets. We're talking about the ellipse, and its secrets, well, they're all around us. So picture this. You're in this huge, beautiful hall. You whisper something, and your friend, who's standing way over on the other side of the room, hears you perfectly. But someone standing right in the middle hears absolutely nothing. How in the world does that happen? It's not magic, I promise. It's geometry. The key, the whole trick, is in the unique architecture of places like the National Statuary Hall in Washington, D.C. They're called whispering chambers, and their amazing acoustic properties come down to one very specific shape in their walls and ceiling. So, okay, how does this actually work? To crack this mystery, we really need to understand the shape that's at the heart of these incredible rooms. You've seen it 1,000 times, but you might not know about its secret properties. This is it, an ellipse. Now, I know, the definition sounds super technical, but the idea behind it is actually pretty simple. It's all about those two fixed points you see on the screen. An ellipse is just every single point where the total distance to both of those fixed points is always the same. And that simple rule is what gives the ellipse its superpower. So what does that definition actually look like in the real world? Let's check out a really simple, hands-on way that anyone can use to draw a perfect ellipse. This is the classic method, and it's brilliant. As you move that pencil around, the string stays tight, right? That means the sum of the distances from your pencil to each thumbtack is always the same. It's just the length of the string. You're literally tracing out the very definition we just talked about. And those two thumbtacks? Yeah, they've got a special name, the foci. That's the plural of focus. These two little points are the secret heart of every single ellipse. And in a whispering gallery, if you stand at one focus, your whisper gets perfectly reflected to the person standing at the other one. That's the trick. Now, to really get a handle on ellipses, we just need a tiny bit of vocabulary. The major axis is just the long way across, and the minor axis is the short way. The endpoints have fancy names, vertices and covertices, and right there in the middle, you've got the center. Just think of these as the basic building blocks of any ellipse you see. Okay, so we've got the physical shape down. Now we're going to translate this into the universal language of mathematics. This is the secret code that lets us analyze and predict exactly what an ellipse is going to do. And this is the secret code, the standard equation for an ellipse that's centered right at the origin. I know, it might look a little intimidating, but just think of it like a recipe. The A and B values are our key ingredients. They tell us exactly how wide and how tall the ellipse is, based on those axes we just talked about. So, how does this recipe work? It's actually super simple. All you have to do is look for the bigger number in the equation. If that bigger number is under the x, the ellipse gets stretched horizontally. It's wider. If it's under the y, it gets stretched vertically, making it taller. It's a simple rule that tells you the shape's orientation in a split second. But of course, not every ellipse in the universe is perfectly centered at 0. So what happens when we need to move it around? Well, the math gives us this really elegant and simple way to do just that. So we start here with our basic ellipse sitting happily at the origin described by our standard equation. This is our home base. And here's the cool part. To shift the center to any new point, let's just call it h comma, we just tweak our equation a little bit. We replace x with x minus h and y with y minus k. You can think of h and k as little joystick controls that let you slide the entire ellipse left, right, up, or down on the graph without changing its shape or size at all. All right, we now have all the tools we need. We understand the shape, we know its parts, and we have the mathematical code. So, let's go back to our original mystery and use this new knowledge to finally solve it. Okay, so here are the actual dimensions of a real whispering chamber. It's 96 feet long and 46 feet wide. Now, in our new math language, that means the major axis, or 2a, is 96 feet, and the minor axis, 2b, is 46 feet. And that gives us our a and b values right away, 48 and 23. Now for the final piece of the puzzle, how do we find the exact location of the foci, those two special spots where you have to stand? We use this simple but incredibly powerful formula, which connects the length, the width, and the location of the foci all together. We have our A and B from the room's dimensions. We have our formula. We can now calculate c, which is the distance from the center to each focus. So the big question is, how far apart do the two people actually need to stand?
The math gives us the answer. When you plug in the numbers, you find that C is about 42 feet. Now, since that's the distance from the center to just one focus, the total distance between the two foci is double that. The two whispers are standing 84 feet apart. That's not a guess, right? That's a prediction made possible by the geometry of the ellipse.
And this is where it gets really cool, because this shape isn't just for neat acoustic tricks. Ellipses are literally everywhere. Medical devices called lithotripters use an elliptical reflector to focus shockwaves and break up kidney stones without surgery. It's the exact same principle as the whispering gallery. You also see the shape in boat keels and airplane wings. And then, on a cosmic scale, it's the shape that defines our entire universe. You know, for almost 2,000 years, we all believed that planets moved in perfect circles, thanks to Aristotle. But then, in the 1600s, this astronomer, Johannes Kepler, makes a totally revolutionary discovery. The orbits aren't circles at all, they're ellipses, with our sun sitting at one of the foci. This single geometric insight changed astronomy forever, and it's the foundation for how we navigate space even today.
So there you have it. From a quiet whisper in a room to the vast sweeping paths of planets, a simple ellipse holds the secret. It really makes you wonder, doesn't it? As you look at the world around you, from a bridge to a coffee cup, what other profound secrets are just hiding in plain sight, waiting to be understood through the language of simple geometry?